You got it? Ready?
Yeah.
All right. Welcome, boys and girls, to another edition of Burbank High Chemistry Labs. And today we're going to do a little something different. We're going to build molecular models. Okay? And you'll be able to see what they look like in 3 dimensions. Right? You've been drawing your Lewis dot structures on paper, and now we're going to build them in 3-dimensional space. And then you and your teacher will talk about the shapes of these. Okay, so in the kit, all right, and normally you and your partner would do this. We got different colored balls and some sticks. The white balls represent hydrogen. The red balls oxygen. Green ball can represent any halogen, but we're gonna do chlorine. You can see. The black balls represent carbon, and the blue balls represent nitrogen. Okay? Now, when you look at the balls, the white balls have one hole in them. Okay, that hole represents an unpaired electron that's looking for a partner. So you can see that the hydrogens have one unpaired electron. If you go down here, the halogens or the chlorines, the green balls, sorry, Mr. Dixon, also have just one hole, right? Because it has a 7th electron, in other words, that needs to be paired up, an odd number. Now, oxygen has 2 holes, the red balls, because it has 2 electrons that need partners. Now, there are some exceptions to this. You would learn that, later on. But these are the general rules of these main elements, right? These are main non-metal elements. All right, the black balls have 4 holes in them. They have 4 electrons that need partners, right? To covalent bond. All right, and then the blue ball has 3 holes in it. Okay, because it has 3 unpaired electrons. Okay, so the balls do not show the paired electrons. Just the hole represents the unpaired electrons. So,
and these sticks are
and the sticks,
the bonding pairs.
Okay, those sticks represent when you bond. So we're going to show you what to do. You want to hold that up? We are going to build these models and then draw them out. Okay? Or write them out as far as Lewis dot structures, not draw them as far as an actual artist.
Yes.
Okay, an artiste. You gotta. Okay.
My brother was the artist in the family.
All right. So we'll show you what to do, or we're gonna show it right now. So we'll start off real simple. I'll get the first one going. Hydrogen.
I'll do oxygen.
Okay. Hydrogen is just H2. Now the goal is to take. So H2. I'm like, okay, that means I take 2 white balls, right? 2 hydrogen balls, and I'm looking at it, how do I plug the holes up? All right. So you take a stick, you plug it up, and there you go. Once all the holes are filled, you finished. So the trick is, when you're doing this lab, is you look at the list of molecules you got to do, and you take the balls that they tell you to take, and you plug all the holes. Once all the holes are plugged, there's nothing else you can do. It is done. So this, and we're coming around and doing this. All right. All right. That represents hydrogen. Okay. All the holes are filled. It's the simplest molecule. Down.
A little bit up.
A little up.
There you go.
Okay. Simplest molecule in the universe. All right. So now I'm going to draw it up here. You would normally just draw it on your paper. So what is, it's H attached to H, right?
That's it.
And if you remember, right, hydrogen only wants 2 electrons. So once you put a stick in hydrogen, he's done. You don't have to add any unshared pairs. Okay? Now, Mr. Dixon.
I'm going to do oxygen.
Oxygen.
Oxygen, you remember, has 6, right? So it's got Oxygen, H.
Is that oxygen? Oxygen?
Okay, so it's got 6, right? So we got 1, 2, 3, 4, 5, 6, say. And we got another oxygen, 1, 2, 3, 4, 5, 6. And you can kind of start to see where these guys could form a bonding pair and these two could form a bonding pair. You'll do your various rules and add them all up, and everybody wants 8 around it. So this guy's got 2, 4. You count the bonding ones as if they own both of them, right? 2, 4, 6, 8. So everybody will have a octet. So how does that look on the model? Well, we use these little bendy ones here, right? When we put the first one in, but you'll notice that both of these red ones still have a hole there. So if we put the second one and just bend it so that it fills the hole, now all the holes are filled, and there's your double bond. Sorry, too high again.
Okay, but isn't it oxygen? Is the oxygen blue?
Oxygen, no.
Oxygen's red.
Oh, okay. Oxygen's
Nitrogen.
red. Oh, I'm wrong. Okay, sorry.
You're not listening to the instructions.
Okay,
Well, I'm hurt, Mr. Ivan.
You're up. Or
You want to do
next one?
nitrogen?
Nitrogen.
I do want me to do nitrogen. Okay.
Okay, so next up, Mr. Iwan's going to do
Nitrogen's blue.
nitrogen. So that would be N2, right?
5 on there.
Okay.
Okay, so now we're going to put together N2. As you know that N2 is a diatomic, so here's the reason why. We're going to show you.
Okay. So, does this work? Does this pen work?
It's your
Is that
pen.
I don't know. Is that the one that you use?
You got 2 black ones.
You want to use the
All
blue?
right.
It looks good.
Okay. So, so with nitrogen, we have you have 2 pairs, and then on each of these sides, you're going to have
There we go.
a single. You're going to have a single electron. Remember that you have 4 sides on the element, okay? On each element. So on each of these 3 sides, you're going to have a single electron. Up here, you have a pair. So that means that you can share these 2, okay? You could share these 2, okay? You can share those 2. So what you would have is you would have nitrogen with a triple bond, and you have lone pairs on the sides, okay? All right, so what you would do is you would take your nitrogen, okay, whoops, thank you, okay, this is crazy doing this, okay, and then you got to somehow do, whoops, did I do that wrong? Oh gosh, okay, sorry, I'm a little bendy. Got to do a little bit of gymnastics here. Okay, so now I've got the triple bond right here. Okay, and you see it's triple bond. It's blue. Okay, and has a triple bond. 1, 2, 3. Okay.
Perfect.
All right.
Excellent.
Okay, who's next?
My turn.
Yeah. What
I
are you
think
doing?
it's Mr. Smith.
Okay, I will do, I get to do water. Number 5 is H2O. Okay, so we're going down the list here. So H2O, so that means, I'll just write it over here, okay? H2O, two white balls and a red ball.
There you go, sir.
Thank you. So we got 2 hydrogens and an oxygen, and I'm looking at it going, how do I plug these holes here? Well, the only way to do it is to do this, right? You just kind of fool around with it. Oh, okay. Let's bring him down the catwalk here. Okay, H2O, all right? So you got 2 H's attached to an oxygen, and water this is called an angular shape or bent, right? Bent. So, and we'll talk about that in class, but that's water right there, H2O. If you can see, all the holes are filled, okay?
Good.
Now let's draw it up here real quick, okay? You could draw it like this, all right? Now remember, oxygen has these 2 guys, these pairs, so you got to put them on there somewhere. you can see oxygen has 2, 4, 6, 8 around him,
Yep.
while the hydrogens are happy with their 2. So. And next.
While you're doing yours, I'm going to erase these to make more room.
Okay.
You know, I have an extra eraser somewhere.
This is kind of gross.
Yeah.
I just use the cloth towels.
I don't have any cloth towels.
Like these?
You can probably buy them. You can just buy like those terry cloth.
Oh, yeah.
Try this. Okay.
Should I do chlorine or?
Yeah.
Chlorine. Okay, so chlorine is a halogen. So we're going to use the green ones, and they bond once because they only want one more electron. So they kind of are trying to steal it from their neighbor here. And so it ends up looking pretty similar. It looks pretty much the same as the hydrogen one, but for an opposite reason. The hydrogen has one to give. These guys have one they want to steal. So, right, each of them have 7, 2, 4, 6, 7. Sorry, chlorine. 2, 4, 6, 7. So this guy really, he's like got one empty space there, right? He really wants an electron. So he sees this one over here and it's like, yeah, I'm gonna take that. And then this guy's thinking the same thing. So you end up with one bond, and this guy's got 2, 4, 6, 8. 2, 4, 6, 8. So they're all happy. Wow.
All right.
Okay, what's the next one?
NH3.
NH3, okay. So NH3, you're gonna have nitrogen, okay. And once again, nitrogen has 3 lone electrons on the 3 sides, so we can actually come along and bring a hydrogen. We can share here, and share here. And so it comes out to be NH3. So that would be nitrogen is blue, and we would do a single bond. Okay. 3 single bonds, and H is white. So we would have NH3. Okay. This is ammonia. Okay, NH3. You notice how it's bent here. If you and this way and this way. Yeah, trigonal pyramid.
Right.
Yeah. But we'll talk
That's
about
what I like
that
about
a
these
little bit later.
models is that it doesn't show it just flat. You know, it still shows the tetrahedral angles.
Yeah.
Yeah, and your individual teacher will go through that with you.
And up here you would have a lone pair,
Right.
2 electrons on the top. It doesn't show it, but you would have these up here on the top. Okay? All right. Who's next? What are we going to do next?
HCl.
Ooh, what do I got? HCl?
HCl.
All right, so hydrochloric acid, HCl. All right. So that's just
Oh, you did the ammonia.
good old HCl. So that's a white ball and a green ball. So, thank you. Got my white ball, got my green ball. They both have one bonding site, right? Right? They both have just one, whoops. They each have a lone electron that wants to hook up, so, right? So they just simply hook up right there. Okay? They decide to share these. That way chlorine has 2, 4, 6, 8, and hydrogen has his 2. So we show that. Remember, these sticks, just a friendly reminder, represent 2 electrons being shared, right? Covalent bonds. So, all right, easy peasy. There we go. Let me bring it over.
Bob will add the.
Right.
That was the
He's
thing.
going to drown out the music.
That was fancy music he had in the last one.
Fancy schmancy. All right, so there's your HCl. It's just a simple molecule, right? Straight across. Okay.
Let me do methane, CH4.
You did a good one.
I get a good one. Well, you got water. Water's a cool one.
Water's cool. All right, so next we got,
Let me dry it off.
Yeah, I gotta get you my.
maybe write the formula up there so they know.
CH4.
CH4.
Okay, so we got one C and it has 4 valence electrons. We have 4 H's and each of them have 1. So you can see how these guys would all end up sharing or fighting over these electrons here. So you end up with just... Now, I know I bring up in my class, I'm sure you guys do too, even though it looks like 90 degrees, it's just because we have it on the plane of the board here. But it's actually, you'll see the model shows us that it's not 90 degrees. So let me get the, got one black one here, need 4 white ones and some bonding electrons. Just a stiff one, okay. So far so good. So now we have CH2, which doesn't exist. CH3, why doesn't it exist? Because it really wants to fill up that octet.
Yeah, that's a good point because, you know, we're showing you, you know, what combinations can exist and what can't.
Right.
Right? These electrons want to be paired and the holes, in other words, the holes want to be filled. So if the holes can't be filled, a certain combination won't work.
And this is tetrahedral. And each of these bonds is 109.5 degrees. Cool.
Nice.
You're up.
Okay.
Somebody.
NCl3.
Bob. NCl3. Ooh.
Okay. Okay, so NCl3.
Is that the one that explodes when you throw it on the ground, or is that
Might
nitrogen
be.
triad? Yeah.
It might be.
Okay, so we
Little
have
poppers.
N. Wow.
Nitrogen trichloride.
All right, so we're doing NCl3, correct?
Right.
Yeah. Okay.
So we have N has 3 unpaired electrons on the 3 sides, and then you have another. You have chlorine. Okay, and that has 1 also. Chlorine has 1 as well, and then you have another one. So what happens is you can share in 3 spots with the nitrogen. You end up with a lone pair on the nitrogen. So what it looks like is you have the lone pair, and then you have your Cl, your Cl, and your Cl.
I forgot all the CLs have those
Have the, yeah,
lone pairs.
lone pairs. Okay, notice that the Cls all have an octet. The nitrogen also has an octet, so they're really happy. They've got everything they want, they're very content, they're very happy. So let's do it. Let's put together our nitrogen has 3, okay. And hydrogen is white, right? Okay, I always get those mixed up. Okay. And
Chlorine's actually green.
Yep, chlorine's green.
oh, whoops,
Hydrogen's
sorry.
white. You're making ammonia again.
Sorry. Oops. Okay, I was just testing you guys
Yeah,
to see
yeah,
if
thank
you're
you.
awake.
We passed.
You passed. You're good. Okay. See, wasn't that fun?
CO2, wow.
Okay, learning is fun. Okay, so this is NCl3. Okay, and you notice once again it looks very similar to ammonia, right? Because you've got, once again, you have the nitrogen here. Before in ammonia, you had the H's on the sides. Now we have chlorine, but it still is the same shape. It's still going to be trigonal planar, trigonal pyramidal. Okay, so trigonal 3-sided pyramid. Okay, all right. What's the
Very
next one?
Ooh, now we're getting into some, OCl2.
call that?
And that means you get the good one.
Oh, wait, there's a good. Okay.
Oh,
Is that oxygen dichloride?
yeah.
It's a,
Yeah, I've never seen it.
I know.
All right, so now we're going to do oxygen dichloride,
Hydrogen cyanide.
Ooh, isn't that dangerous?
OCl2. So oxygen and 2 chlorines. So I need a red ball and 2 green balls. I got my red ball, 2 greens. All right, so I'm looking at it. I'm like, okay, I got to fill the holes. So there we go. There's something. Oh, one more hole here. Oh,
There we go.
there we go. Yeah, so it wouldn't work as just OCl. Yeah, oxygen monochloride, because oxygen would be unhappy with that lone electron there. So that unpaired electron, I should say. There we go. OCl2, very similar structure to water.
Yeah.
Let me draw it up here. So,
Yeah, you would think it would be a straight line from the Lewis structure.
Exactly.
But it's not.
Yeah.
oh yeah, if you drop more like it's supposed to look, it would be like this, right?
Yep.
Alright. Okay, so you can see, right, the single electron here and the single electron there hooked up. And then the single electron here, and then the other electron that was by itself hooked up there. So there's OCl2. It's a nice angular, oh yeah, let me humor me with this, right? All right, there it is.
Mr. Smith was a hand model.
Right, I can't help it. It's just, you know, my nature. Okay.
Okay.
HCN?
Oh, Mr. Dixon gets a good one.
Iron cyanate. What we used to kill
Yes, this is a good one.
Wow.
I'm jealous. He gets the good one.
HCN. So we got 3.
That works really good in Kool-Aid.
Is that what they
Jim Jones.
Jonestown? Man, that's nasty.
Which the kids have no idea what we're talking about.
No. Well, most adults probably don't either, sadly. One hydrogen has 1, carbon has 4, nitrogen has the 3. So I'm just going to build it first, and then we'll see that the holes here determine
If you build it, they will come.
they will come. Okay, so we got 1 carbon.
I heard about that new HCN casino.
Okay, so we have the 1 hydrogen, and I still got 3 holes now on the carbon, and I need to connect it to a blue one, which is nitrogen, and it has 3 holes. So guess what? We got some doubling and tripling bonds going on here. We got 1 in there, got 2 more holes on each of them. Bendy, bendy. All right, we're almost there, but still 1 hole here, 1 hole here. And you can see that we're bending it and putting a lot of strain on there, and that actually happens with the electrons too. They get kind of crowded so that they're not terribly happy being so close together, but that's the best way to go. Oops, get closer. So we got a carbon triple bonded to a nitrogen and a single bond to the hydrogen.
That's a cool looking
It's like a
molecular. Yeah, it's like a spaceship.
Like a Russian satellite.
a Russian satellite.
It's Sputnik.
triple bond, nitrogen, got a lone pair.
I see a CCCP.
So this guy's got 2, it's happy. This one's got 8, it's happy. This one's got 8, it's happy.
Nice.
Okay, shall I do H2?